Page 21 to 26. The Big Bang Never Happened. Eric J. Lerner, 1991. 0.1. Introduction. When leading scientists publicly predict that science will soon reach its ultimate goal, that within a decade everything will be explained, you can be sure that they are wrong. A century ago, one of the leading scientists of the day, Lord Kelvin, stated that the future of physics lay in the last decimal place. All the main problems, he declared, had been solved, only further accuracy was needed. Yet within 2 decades, the discovery of radioactivity, the theory of relativity, and the development of quantum mechanics had thoroughly transformed physics and profoundly changed humanity's view of the universe. Today we again hear renowned scientists, such as Stephen Hawking, claiming that a theory of everything is within their grasp, that they have almost arrived at a single set of equations that will explain all the phenomena of nature: gravitation, electricity and magnetism, radioactivity, and nuclear energy, from the realm of the atoms to the realm of the galaxies, and from the beginning of the universe to the end of time. And once again, they are wrong, for quietly, without much fanfare, a new revolution is beginning which is likely to overthrow many of the dominant ideas of today's science, while incorporating what is valid into a new and wider synthesis. The Big Bang theory of cosmology, of the idea that the universe originated in a single cataclysmic explosion some 10 or 20 billion years ago, was popularized in the 50s and 60s, and has become central not only to astronomy, but to all current theories of the basic structure of matter and energy as well. Yet in the past few years, observation after observation has contradicted the predictions of this theory. Rather, such observations are far more consistent with new theories based on the idea that the universe has existed for an infinite time without beginning or end. As yet, such alternative theories, known as plasma cosmology, have been developed by only a relatively small group of physicists and astronomers, the most notable being Swedish Nobel laureate Hans Alfvén. But as the evidence mounts, more and more scientists are questioning their basic, long-held assumptions. The emerging revolution in science extends beyond cosmology. Today the study of the underlying structure of matter, particle physics, is intimately tied up with cosmology. Of the structure of the universe, theorists argue, is the result of events in the first instance of time. If the Big Bang hypothesis is wrong, then the foundation of modern particle physics collapses and entirely new approaches are required. Indeed, particle physics also suffers from an increasing contradiction between theory and experiment. Equally important, if the Big Bang never occurred, our concept of time must change as well. Instead of a universe finite in time, running down from a fiery start to a dusty, dark finish, the universe will be infinite in duration, continuously evolving. Just such a concept of time as evolution is now emerging from new studies in the field of thermodynamics. The changes in these 3 fields, cosmology, particle physics, and thermodynamics, are merging into a single global transformation of how science views the universe, a transformation comparable to that which overthrew the Ptolemaic cosmos and initiated modern science. This book is a first effort to describe that emerging revolution and its implications, since it gives the view of what is at the moment a minority of the scientific community. The ideas presented here are far different from, and contradictory to, the most common beliefs about cosmology and fundamental physics. Yet what I describe here is not a fringe view, a Velikovskian fantasy. It is a summary of work presented in thousands of papers published by leading technical journals, work that, although not yet widely accepted, is beginning to be widely discussed. In the winter of 1988, for example, Alfvén was invited to present his views to the Texas Symposium on Relativistic Astrophysics, one of the most important conferences of cosmologists. My aim is to explain these new ideas to the general reader, one who is interested in the crucial issues of science but who has no special training in the subject. I believe that if the issues are presented clearly, readers will be able to judge the validity of the arguments involved in this debate. The ultimate test of scientific theories is observation, and I will emphasize how observations conflict with, or support, various cosmological ideas. But this debate involves more than just 2 views of the universe and its origins. It is a struggle between 2 different ways of learning about the universe. 1. The method of learning from observation, is used by the vast majority of scientists today and by those who are proposing the new ideas in cosmology. The other method, advocated by mainstream cosmologists and particle theorists, is the deductive method, mathematically deducing how the universe must be. Both methods date back millennia, and over time they have alternately dominated the study of the universe and its origins. To understand the present debate in cosmology, we must understand something of this long history, how the ideas themselves a universe without a beginning, a universe created from nothing at a single momenta came into existence. For the only real way we have of judging these methods is by their results of the consequences they had for the development of science, and for the development of society. This history, then, involves more than the history of cosmology, or even of science. One of the basic, although far from original, themes of this book is that science is intimately tied up with society, that ideas about society, about events here on Earth, affect ideas about the universe and vice versa. This interaction is not limited to the world of ideas. A society's social, political, and economic structures have a vast effect on how people think, and scientific thought, through its impact on technology, can greatly change the course of economic and social evolution. So now, as in the past, the evolution of society and the evolution of cosmology are intertwined, one affecting the other. This interaction must be understood before one can comprehend what is happening in cosmology today. Otherwise it is a mystery how certain ideas develop, come to the fore, and are then abandoned, how the vast majority of cosmologists can arrive at conclusions so clearly contradictory to observation. Today Big Bang theorists see a universe much like that envisioned by the medieval scholars, a finite cosmos created ex nihilo, from nothing, whose perfection is in the past, which is degenerating to a final end. The perfect principles used to form this universe can be known only by pure reason, guided by authority, independent of observation. Such a cosmic myth arises in periods of social crisis or retreat, and reinforces the separation of thought and action, ruler and ruled. It breeds a fatalistic pessimism that paralyzes society. By contrast, the opposing view, plasma cosmology, is empirical, a product of the scientific method of Galileo and Kepler. Its proponents see an infinite universe evolving over infinite time. The universe can be studied only by observation. There is no final answer in science and no final authority. This approach, binding together thought and action, theory and observation, has proved, over the ages, to be a weapon of social change. The idea of progress in the universe has always been linked with the idea of social progress on Earth. 0.2 The structure of the book. The first part of this book explains the ongoing debate in cosmology. Chapter 1 begins with the evidence that the Big Bang theory is wrong, and that alternative theories, based on the study of electrically conducting gases, called plasmas, are probably right. I then take a long step back to trace the history of the cosmological debate. Chapter 2 shows how the basic concepts of both the empirical and the deductive methods arose in ancient Greece and how they were tied up with the conflict between free and slave labor. The deductive method's disregard for observation and practical application of science originated with the slave master's disdain for manual work, while the empirical method system is based on free craftsmen and traders combining theory and observation. In the first swing of the cosmological pendulum, the deductive method became dominant, leading to the static and finite universe of Ptolemy. The central idea of modern cosmology, the origin of the universe from nothingness, then arose not from Genesis but from the ideological battles of the 3rd and 4th centuries AD. As Roman society disintegrated and the basis was laid for feudalism, the Church Fathers Tertullian and St. Augustine introduced the doctrine of creation ex nihilo as the foundation of a profoundly pessimistic and authoritarian worldview, a cosmology that denigrated all earthly endeavor and condemned material existence as created from nothing, next to nothing, inevitably decaying from a perfect beginning to an ignominious end. This cosmology was to serve as the philosophical and religious justification for a rigid and enthralled society. Chapter 3 describes the next long swing of the pendulum and the centuries of struggle that led to the scientific revolution. The rise of a new and more profound empirical method went hand in hand with the rise of a new view of the universe infinite in space and time, without origin or end, and with the rise of a new society, one based on free labor. By the middle of the 19th century, the scientific view of the universe was that of an unending process of evolution, as the revolutionaries of the 18th and 19th centuries saw an unending process of social evolution and progress. The Big Bang in 20th century cosmology constitutes a startling return to the discredited medieval concepts. As Chapter 4 details, the deep social crisis of the present century gave credence to the old philosophical view of a decaying universe, degenerating from its perfect origins, and to the deductive method. It is from these primarily philosophical premises, rather than from observation, that present-day cosmology developed. For this reason, as we will explore in Chapter 4, the repeated conflicts between theory and observation that have dogged the Big Bang never led to its abandonment. However, the challenge to the Big Bang did arise from observation. Chapters 5 and 6 describe how plasma cosmology grew out of the laboratory study of conducting gases and had its roots in the advancing technologies of electromagnetism. As observations have extended outward from the Earth and the Solar System to the galaxies and the universe as a whole, the predictions of plasma cosmology have been increasingly confirmed. The second part of the book deals with the implications of a universe that is infinite in space and time, continuously evolving. In Chapter 7 I examine how new discoveries in the nature of time show that such a cosmos can exist indefinitely without running down. In fact, the universe is characterized neither by decay nor by a random, aimless meandering or by the automatic progress of late 19th century concepts. The cosmos, and indeed any complex system, progresses only through a series of crises whose outcomes are not predetermined and can lead, over the short run, either to new advances or to retrogression. Progress, the acceleration of evolution, is a long-term tendency of the universe, but it is far from a smooth and mechanical process. Chapter 8 looks at the equally profound problems that arise with the conventional ideas of matter if the Big Bang is refuted. Not only the most recent theories but much of the underlying structure of physical theory suffers from crucial inconsistencies that remain to be resolved. Finally, in Chapters 9 and 10, we look at the impact an infinite cosmos has on religion and society. As in the 16th century, the two approaches to cosmology today imply profoundly opposing reactions to a deepening crisis. Page 26.